In 2024, Google's Willow chip solved a computation in 5 minutes that would take classical supercomputers 10 septillion years. Your encryption was designed for classical computers. What happens when quantum computers come for your data? Welcome to AmtocSoft. I'm your host, and today we're covering one of the most important security shifts in software history: post-quantum cryptography. By the end of this video, you'll understand exactly why your current encryption has an expiration date, which algorithms NIST has approved as replacements, and the concrete steps you need to take as a developer right now, not someday, right now. Let's break it down. Here's the core problem. Most of the encryption you use today, RSA, elliptic curve, Diffie-Hellman, relies on mathematical problems that are extremely hard for classical computers. Factoring a 2048-bit RSA key would take a classical computer millions of years, but a sufficiently powerful quantum computer running Shor's algorithm could do it in hours. This isn't theoretical. IBM, Google, and dozens of startups are racing toward fault-tolerant quantum computers. Current estimates put cryptographically relevant quantum computers arriving between 2029 and 2035. That sounds far away, but here's the catch. Attackers are already harvesting your encrypted data today, planning to decrypt it later when quantum computers arrive. This is called the harvest now, decrypt later attack, and it means the quantum threat is already active for any data that needs to remain confidential for more than a few years. Medical records, financial data, trade secrets, government communications, all of it is at risk right now. In August 2024, NIST finalized 3 post-quantum cryptographic standards after an 8-year evaluation process. First, ML-KEM, formerly known as Crystal's Kyber. This is for key encapsulation, meaning it replaces the key exchange in TLS handshakes. It's based on lattice problems, specifically module learning with errors. Think of it as hiding a signal in a massive field of noise that quantum computers can't efficiently separate. Second, ML-DSA, formerly Crystal's dilithium. This is for digital signatures, replacing RSA and ECDSA signatures, also lattice-based. It's being adopted for code signing, certificate authorities, and software verification. Third, SLH-DSA, formerly SBHINCS+. This is a hash-based signature scheme. It's slower but uses completely different math from the lattice schemes, providing a backup if lattice problems are ever broken. All 3 are now formal FIPS standards. This isn't experimental. This is production-ready cryptography. Let's talk about when you need to act. The NSA has mandated that all national security systems must migrate to post-quantum algorithms by 2035. But here's what most developers miss. The migration itself takes years. Identifying every place cryptography is used in your systems, testing replacements, updating dependencies, coordinating with partners and vendors, that's a multi-year project for any organization. If you start migrating in 2030, you're already behind. Chrome and Firefox are already shipping hybrid TLS with ML-KEM. AWS, Azure, and GCP are adding post-quantum options to their key management services. Signal migrated its messaging protocol to post-quantum in September 2023. Apple's iMessage followed in 2024. The industry leaders aren't waiting. They're shipping post-quantum now, and using hybrid approaches, running classical and post-quantum algorithms in parallel so that even if one fails, the other still protects you. The hybrid approach is the smart strategy for migration. Instead of ripping out RSA and replacing it entirely, you run both algorithms simultaneously. In a hybrid TLS handshake, the client and server exchange both a classical ECDH key and an ML-KEM key. The final session key is derived from both. If quantum computers never materialize at scale, your classical algorithm still works. If they do, Your ML-KEM key protects the session. This is exactly what Chrome is doing today with X25519 plus ML-KEM 768. You might already be using post-quantum crypto without realizing it. Here are the 5 concrete steps every developer should take. Step 1. Audit your cryptographic inventory. Find every place your code uses RSA, ECDSA, ECDH, or AES-128. Tools like CryptoSense and IBM's Quantum Safe Explorer can scan your codebase automatically. Step 2. Update your TLS libraries. OpenSSL 3.5 and BoringSSL already support ML-KEM. If you're running Node.js, Go, or Python, check that your TLS library version supports post-quantum key exchange. Step 3. Switch to AES-256, where you're using AES-128. While AES isn't broken by quantum computers in the same way RSA is, Grover's algorithm effectively halves the key strength. AES-256 drops to 128-bit security under quantum attack, which is still safe. AES-128 drops to 64-bit, which is not. Step 4. Plan your certificate migration. Your CA certificates, code signing keys, and long-lived secrets need to move to ML-DSA signatures. Start with non-critical internal systems and expand outward. Step 5. Enable hybrid mode in your load balancers. Cloudflare, AWS Alb, and Nginx all support hybrid post-quantum TLS. Turn it on. Your users get post-quantum protection transparently. Three mistakes I see developers making. First, assuming this is a future problem. If your data has a shelf life longer than 5 years, it's a today problem because of harvest now decrypt later. Second, waiting for your framework to handle it. Libraries update, but they don't automatically reconfigure your existing deployments. You need to actively enable post-quantum settings. Third, ignoring symmetric encryption. Everyone focuses on RSA and ECC, but if you're still using AES-128 or SHA-1 anywhere, those need attention too. Grover's algorithm weakens all symmetric schemes, so you need to double your key sizes. Here's a simple decision framework. Ask yourself, does my data need to be confidential beyond 2030? If yes, you need post-quantum protection now. Enable hybrid TLS, audit your key sizes, and start planning certificate migration. If your data is short-lived, like session tokens or temporary API keys, classical crypto is fine for now, but still plan the migration because your infrastructure should be ready before you need it. For signatures, the calculus is different. Code signing keys and certificate authorities should migrate sooner because a forged signature can retroactively compromise trust in everything you've ever signed. Let's recap. Quantum computers will break RSA and ECC. The timeline is 2029 to 2035, but Harvest Now attacks make this urgent today. NIST has finalized 3 standards: ML-KEM, ML-DSA, and SLH-DSA. Use hybrid approaches. Run classical and post-quantum in parallel during migration. Start your cryptographic audit this quarter, not next year. If this helped you understand the post-quantum landscape, hit subscribe and the bell icon so you don't miss our deep dive on supply chain security coming next. Drop a comment. Has your team started thinking about post-quantum migration? I'd love to hear where you're at. See you in the next one.